To learn more about the electrical part of the International Residential Code, or IRC, firstly, consider the Electrical Inspection Channel, which can be found online. Secondly, you can purchase the International Residential Code Electrical Codebook directly from the International Code Council. The IRC is widely adopted for 1- and 2-family dwellings across most states in the United States. However, there are exceptions. California uses the California Building Code, or CBC. Massachusetts uses the Massachusetts State Building Code, known as 780 CMR. New York City operates under the New York City Construction Codes, or NYSEC. It is important to note key differences can exist between the IRC and specific state or local energy codes. For example, the Michigan Energy Code may have more stringent requirements than the IRC, particularly in areas such as lighting, power density, insulation requirements, and window performance. The Michigan Energy Code typically has lower lighting power density requirements than the IRC. This means that buildings are required to use less power for lighting under the Michigan Energy Code. Also, the Michigan Energy Code generally mandates higher levels of insulation for ceilings, walls, and attics compared to the IRC, enhancing energy efficiency. Furthermore, the Michigan Energy Code usually requires windows with higher thermal resistance, known as U-factor, and lower solar heat gain coefficient, or SHGC, values, improving the building's thermal performance. To effectively learn the IRC electrical code, consider these tips. 1. Attend code interpretation classes. Local building departments often provide classes on code interpretation, which can be a great way to learn the code. 2. Join a professional organization. Organizations such as the National Electrical Contractors Association, or NECA, offer code training and resources. 3. Study code books. Thoroughly read and understand the IRC electrical provisions. 4. Use online resources. Visit the International Code Council, or IC, website and other online forums for code-related questions and discussions. Seek assistance from qualified professionals such as an electrician, code inspector, or building department official for guidance and clarification on specific code requirements or interpretation. These experts can offer valuable insights and help ensure compliance with the applicable codes. Understanding the electrical aspects of the IRC is crucial for ensuring safe and compliant electrical installations in residential buildings. This involves a comprehensive understanding of various articles and sections within the code, covering topics such as general requirements, wiring methods, circuit protection, grounding, and equipment installation. The IRC provides detailed guidelines for electrical systems in residential buildings, aiming to safeguard occupant and property from electrical hazards. Grounding and bonding are essential for electrical safety, ensuring a low impedance path for fault currents and minimizing the risk of electric shock. The IRC specifies requirements for grounding electrodes, conductor sizing, and bonding of metallic components to establish an effective grounding system. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. The IRC outlines the selection and installation of these devices based on the ampacity of conductors and the type of equipment being protected. Wiring methods dictate how electrical conductors are installed and protected within a building. The IRC specifies acceptable wiring methods, including non-metallic sheet cable, or NM cable, electrical metallic tubing, or EMT, and rigid metal conduit, or RMC, based on the application and environmental conditions. The IRC includes specific requirements for various types of equipment, such as lighting fixtures, appliances, and electrical panels. These requirements cover installation, wiring connections, and safety features to ensure proper operation and prevent hazards. Understanding these fundamentals is essential for anyone involved in electrical work in residential buildings. This knowledge base includes understanding voltage drop calculations, box fill calculations, and conduit fill calculations. Voltage drop refers to the decrease in voltage along a conductor due to its impedance and the current flowing through it. Excessive voltage drop can cause malfunction of electrical equipment. The IRC provides guidelines for minimizing voltage drop to ensure proper performance. Box fill calculations determine the maximum number of conductors, devices, and fittings allowed in an electrical box. These calculations ensure that the box is not overcrowded, which could lead to overheating or damage to conductors. Conduit fill calculations determine the maximum number of conductors allowed in a conduit based on its size and type. Proper conduit fill ensures that conductors can be easily installed and that heat can dissipate effectively. Proper wiring and connections are critical for electrical safety and reliability. The IRC specifies requirements for making secure and properly insulated connections, using approved wiring methods, and protecting conductors from physical damage. Electrical inspections are conducted to verify compliance with the IRC and other applicable codes. Inspectors examine electrical installations to identify any violations and ensure that the work meets the required safety standards. The National Electrical Code, or NEC, often influences the IRC. While the IRC is a standalone document, it often references or incorporates provisions from the NEC, which serves as the primary standard for electrical installations in the United States. The IRC is tailored for 1- and 2-family dwellings, while the NEC covers a broader range of electrical installations, including commercial, industrial, and residential buildings. Staying updated with the latest code changes and interpretations is essential for electrical professionals. This can be achieved through continuing education courses, industry publications, and participation in code-making panels. The electrical industry is constantly evolving with new technologies and safety standards. Staying informed about these changes is critical for providing safe and reliable electrical services. Specific sections within the IRC address various aspects of electrical installations. Chapter 34 covers general requirements. Articles within this chapter provide fundamental rules and guidelines for electrical work. Chapter 35 covers wiring methods. This chapter details acceptable methods for installing electrical conductors. Chapter 36 covers equipment over 600 volts, nominal. This chapter addresses specific requirements for high-voltage electrical systems. Chapter 37 covers special occupancies. These articles address unique electrical requirements for specific locations such as hazardous areas. Chapter 38 covers communication systems. This chapter covers wiring and installation of telephone, internet, and cable television systems. Chapter 39 covers tables. These tables provide guidance on conductor ampacity, box fill, conduit fill, and other calculations. These chapters and their associated articles provide a comprehensive framework for electrical installations in residential buildings. Proper application of these provisions is essential for ensuring safety and compliance. Understanding the scope and purpose of each article within the IRC is critical for applying it correctly. The IRC is designed to provide a minimum level of safety for electrical installations. It is important to note that meeting the minimum requirements may not always be sufficient for ensuring optimal performance or energy efficiency. Staying current with code updates, seeking clarification from code officials, and participating in continuing education are essential for electrical professionals. These efforts help ensure that electrical installations meet the highest standards of safety and quality.